Hello, and welcome to McMace Research. Today, we'll be talking about the utility maximization problem of a consumer and how we could end up deriving the indirect utility function. So by way of this, get ready and let's start. Right, so this is going to be a very somehow brief, yes, assumption. When you go to watch the video, you can come back and then continue to save time. Let's go ahead. So today we continue to focus on the utility maximization problem, describe the Walrasian demand correspondence once more, and then how to derive the indirect utility. Although there's a special video on the indirect utility function, you can visit it and then get more insight from there. Right. So by way of just a little bit of introduction to us, the rationality assumption, we assume completeness and transitivity. You can go and check it out again. And for the continuous preference relations, we are saying that the consumer should exhibit jumps in his preferences. He has to be consistent. Okay. And then the non-associated preference assumption suggests that there should be no point that the consumer should be satisfied. He should always want more. He should always want more. Okay. Each of those assumptions has implications for our studies today. So now let's look at the utility maximization problem. Now you study the consumer's behavior all this while. The center of this consumer's behavior is how much am I going to get from consuming this commodity? And so you want to assess the maximizing utility for this consumer. Out of any bundle, out of any wealth with given prices, the consumer wants to know the exact satisfaction, the exact utility he wants to derive, the maximum value that he will ever derive. And that is the utility maximization problem. Now, he would also want to think, okay, so if I'm going to get this exact utility satisfaction, then how many of X and Y should I consume to give me that maximum satisfaction? So the focus of utility maximization problem will help us end up achieving the maximum utility, as well as, so first you're going to achieve the maximum utility, and then we're able to determine how many of X and Y that would give us this maximum utility. Okay, so just so we know. Now, with a given utility function, there are always going to be constraints, and the constraint will be the budget constraint. So with a given budget, the consumer wants to know how many he can consume to achieve this level of satisfaction. Now, your budget needs to hold some assumptions. First, your assumption has to be, your budget has to be compact. And compactability here means that we expect all your expenditure to be affordable, such that for any bundle that you want to consume, it has to be within the budget shade, the budget area. You know, your expenditure should be within the affordability. Now, when we say a budget is closed, it means that you've spent all your resources. So all your expenditure has been equal to your wealth, and then you've closed your budget. So the consumer, to be able to maximize his satisfaction, he needs a budget that is either compact or it is also a closed budget. Means that there is no saving and there's no borrowing. Okay. So now let's move on and start with the maximization problem for the consumer. Great. So with the consumer, he has a very dynamic characteristic, which we call the Walrasian demand correspondence. I bet you remember this correspondence again. We started in our initial video. You can go and check it out. But let me just remind you. So the Walrasian demand correspondence suggests that when you have a given budget set, let's say 10 cedis or a $10 wealth, you can use that $10 or 10 cedis for different consumption bundles. 1 car, 1 orange. 2 cars, 1 orange, all equal to $10. That is what we call the Walrasian demand correspondence. So we are viewing your $10 or 10 cedis as being able to afford different combinations. So see from the graph here, consider this budget line. This budget line at a point in time is able to offer demand at this point. So one, that same budget demand, that same budget affords this combination. Two, the same budget, the consumer can be able to choose different combinations, same level of satisfaction. So this utility UHART is set to have what we call the multi-value budget set. It means that the same budget can afford different combinations. Now, consider the same budget line, but with utility, the initial utility. There is only one possible optimal consumption level. So that budget line has a single value or has only one element in the optimal set, which means that it can be used for that particular bundle set. So note this difference. When a budget set is able to afford you different combinations, then it is multi-valued. So it will have multiple solutions, optimal solutions, because they're going to have different intercepts where the slope of the difference curve is going to be the slope of the budget line in two different places. Now, where we have single value, then it means that it's going to be one optimal point. Great. So understand this, and then we shall be able to have a good discussion. So let me just clear, and then we go on from here. Great. So just like we said, when an optimal set, a budget set, is able to give you different options, then we are describing that as a Wallacean demand correspondence, which can be shown with this graph over here, as you can see. So just as you can see, we are able to show different, just like you can see. So different combinations at this point, at this point, at this point, at this point, at that point, all by the same budget line that can afford you all these combinations. So it's called multiple solutions. Now, it could also happen that we don't have one budget set. Sorry, let me just come back again. So just as we showed here, this is single solution, but this is multiple solution. Great. So know this. When a budget set is known to have multiple solutions, then we are going to describe that budget set as being convex. Okay. When that budget set is able to afford so many combinations, we describe that budget set as being convex. On the other hand, when a consumer is indifferent between several alternatives, that utility curve is said to be quasi-concave. Put that aside. Let me just refresh again. By extension, when a budget set can afford only one possible combination, then it is strictly convex. And when a utility function only affords one bundle which the consumer has no other option, then that utility function is strictly quasi-concave. So where a strictly quasi-concave utility and a strictly convex budget line intersect, they produce a single value optimal set. And that set is what we are going to describe over here. So you can see that this set will exhibit a single element, single value, if the utility is strictly quasi-concave. That is, there's only one alternative. Or the budget line is strictly convex. It means that it can afford only one possible set. On the other side, when the budget line is described as convex, it means that it can afford different combinations, just like the multi-value. And it intersects with a utility function which is quasi-concave, means that there are several combinations to which the consumer is indifferent. So when we have an indifference curve, which is quasi-concave, and a budget line, which is convex, when they intersect, they produce what we call the multiple solution, where we have multiple sets for the consumer, and that is the multi-value. So note that as we advance, because we are going to describe them in detail. So just usually by the assumptions, the Wallacean demand correspondence, as we know, is homogeneous of degree 0, and it obeys the Wallacean law. So we've said that over and over. Great. So just as we also said, the Wallacean law, the last assumption, it says that there has to be non-satiation. The consumer would always have to yearn for more. And that means that when your expenditure is less than your wealth, Wallacean law says that there should be a pressure on you to spend all your resources. So if with a given sample, you chose commodity X, you spent on commodity X, you've achieved optimality. So what would you spend the remaining of your wealth on? You're going to spend it on something else, but not X anymore. Now, at the point you spend the remaining balance on another commodity X, another commodity, but not X, at that point in time, that commodity is now preferred to commodity X. And that breaches the consistency assumption. Because at any point in time, if you put X and Y before you, and you chose X, then by the lexicographic assumption, preference assumptions, you should equally prefer the X. Again, anytime it meets Y, you should pick X. But the moment you've picked X and you are reached a utility level, which you are satisfied, but there's excess funds, and you need to spend that funds, you definitely end up spending it on something else which you would value more than the X. And that point in time, you've refuted the lexicographic preference assumptions. Great. So that is expressed in our next slide, and let's see how it is being refuted. So take a critical look at X here. Suppose you're already here consuming at this bundle X, and then you are within the budget line. So you've not reached the budget line. It means that there's excess funds for you to spend. So you could either move on to this point here. So gradually, you'll be moving to the budget line. At any other point here, you are going to choose more Y over X. The reason is that you're already satisfied with bundle X. So choose another bundle here, and you're going to see that there's going to be more of the other commodity than the X. So now you have refuted the consistency assumption. So the Wallacean non-satiation principle is critical. It helps us to achieve the Wallacean law, but it ends up refuting the consistency assumption of the lexicographic ordering or the consistency assumptions of the preference-based approach and that of the choice-based approach. Okay, so all these conditions, we've treated them, and I hope you could remember by now. Right, now let's look at the Wallacean demand correspondence and explain what we mean by the quasi-concavity. I did that explanation earlier on, but let me just take it over again. Now, when the budget line is described to be convex, if it is convex, it means that you can choose different combinations, which are all affordable. Now, if all of them are affordable, then you can pick portions of both bundles. You can pick portion from bundle B, and you can pick a portion from bundle A. And that new bundle should also be affordable. I hope you get me. Perfect. So that is what we have expressed here. Assume the initial bundle is less than your wealth. So there's excess. Then another expenditure on a new bundle is also less than your wealth. So it means both bundles are affordable to you. Now, if both bundles are affordable, then to consume all your wealth, you can also spend part of the first and a portion of the second. And that should also be less than your total wealth. Okay, now if bundle A is, let's say, 6 cedis, bundle B is, say, 8 cedis, and you have 20 cedis, what does it mean? It means you can pick part of A, part of B. So part of 6, let's say 3 cedis, part of B, let's say 4 cedis, and that should be 7 cedis. 7 cedis is also less than your total wealth, 20 cedis. That's just this implication of the concavity of the utility function. So it suggests that when you have two utilities or two bundles, which are all indifferent to you, and they are also affordable to you, then you can pick portions of both commodities, which would equally be affordable to you. So that is the implication of the concavity and then the convexity of the Wallacean demand function. Good. So as you can see, if two bundles, X and Y, are affordable, then any convex combination of these bundles is also affordable. Perfect. So we can have a look at it from here. Let's take the first diagram from A. You can see all these points, X, X11, and X1, they are indifferent. They give same level of satisfaction. On that indifference curve, that is quasi-concave. And the budget line is convex because it can afford all of them, either of them. So we are having multiple solutions from here, multi-value. So the demand that will be derived from here is going to be a multi-purpose demand or multi-value demand. But take a look at this diagram. This is one solution. This is another solution. But take a look at this one. This is only affordable, single value. So this happens when the utility shows no alternative. So you are stuck. That's just what you have. Giving one bundle, one budget set, then you're going to reach out to what you call the Wallacean demand function, not Wallacean demand correspondence. The moment you talk about Wallacean demand correspondence, you're talking about the first diagram, where we have several bundles being afforded by the same budget. But when we talk about the Wallacean demand function, single value, one commodity, one bundle afforded, but no alternatives. Great. So suppose your utility function is strictly quasi-concave, then your demand function will also be strictly quasi-concave, quasi-convex, strictly convex, as in this part of the diagram. Perfect. Now, there's another part of it that you would also want to see. Anytime you now arrive at talking to the single value demand function, then the utility function and then the budget set, they intersect and their slopes are equal. So that's the utility maximization condition, like we already know. And so this diagram, this is shown over here. This is the utility maximization condition. It only happens for single value. Okay, strictly quasi-concave utility curve and a strictly convex budget line. That produces the interior solution. But the reverse produces what you call the boundary solution. But we are more inclined to this part of the diagram. And of course, you can refer to this differentiating the first order conditions, and you solve for X or Y, then you're going to get a lambda Py. So we are going to talk about this some other time. But the first order conditions helps us to derive the lambda. Okay. Now, let's just also take a look at the Walrasian demand correspondence. Just like we showed in the single valued condition, always the slope of the budget line will be equal to the slope of the indifference curve will be equal to the slope of the budget line. Need the slope of the budget line, that's the price ratios. I need the slope of the indifference curve, which is the marginal rate of substitution, commodity substitution. So with a single value and an interior solution, you are going to arrive at this condition where the price ratios will be equal to the marginal rate of commodity substitution. And that is where you'll be able to derive the optimal values of X and optimal value of Y that will maximize your utility. And so in our next video, we are going to put figures to these theories so that you could have a feel or appreciate what we are talking about. So in the boundary solutions, you see that the utilities will not be the same. The utility and then the X slopes will not be the same because you're going to compute it at where X is equal to 0. Okay. So that is how we'll be able to achieve the utility maximization problem. You first take the differentiation of the utility function, where you're going to derive the slope of the budget line and the slope of the indifference curve. When they are equal, then you arrive at the marginal rate of commodity substitution equal to the price ratios. Then you solve for X and Y's over there, and that gives you the optimal consumption level. Put it into the utility function, and that gives you the maximum utility. That's how we're going to maximize our utility. Now, let's just take a quick look at the indirect utility also and see. Now, with the indirect utility, what we are saying is that the consumer is not going to maximize his utility based on the quantities anymore, but rather with respect to the prices and the wealth of the consumer, the prices and the income of the consumer. So for each time there is a utility, the consumer is looking at the price and wealth that will give him that utility, but not with respect to the optimal X and optimal Y's. Okay, so the indirect utility also has assumptions, degree, homogeneous of degree 0. We've talked about that. It is also strictly increasing in wealth, but non-increasing in prices. So you can understand that one also. So the more price increase, the less you're able to afford, your wealth reduces. But the more your wealth, the more you're able to consume. So that's why the indirect utility function shows a non-increasing relationship with price, but a non-decreasing relationship with the wealth. And you can take another time and look at how to derive the indirect utility function mathematically. There's a video on that. I want you to pay attention to it and then come back to this lesson again. Right. So let's just finish up from here. So the indirect utility function, there is an indirect utility function. So if an indirect utility function from a given commodity is less than your total utility, let's assume your utility is 200 and a given commodity X gives you a utility of 50. And there's another utility for another consumption which gives you 100. Both 150 are lesser than your total utility you can ever achieve, which is 200. So it means that you can consume both of X, both of Y, or portions of X and portions of Y, which would also be lesser than your total utility. So that is the same as we did. Great. So it means that your total expenditure, okay, on commodity X and that on new commodity at a new price, it would surely be less than the wealth and the second wealth also. Now, let me take it again from here. We are saying that this is the demand, and it's a new demand. Okay, this at a new price, at an old price. If this expenditure is less than how much you can afford, that means that you can consume another thing, which is also less than what you can afford. Now, if both are lesser than what you can afford, such that the budget is convex, then it means that you can consume portions of both. So the portion is what we have represented by the alpha. So portion of the expenditure on the first and portion, the remaining portion on the other. Which means that if it is convex budget, both utilities should also be lesser or should also be affordable than the percentages spent on both utilities. I believe that is clear. Great. So with this, so if initial expenditure is less than your wealth and the utility is also less than initial utility, then there's a remaining part of the utility which is also there for you to consume. And that comes up with the second utility. So at a new price, if you're able to consume less, which will be less than the wealth, then there's another budget set which you are going to consume, which is going to give you another possible solution. So a mix of this, a mix of that is also feasible. It's both affordable and also indifferent. So take a look at this diagram. This is the initial demand. Now, the initial demand has this budget. Okay. So this budget intersects this utility and gives you this optimal point. Right. Now, this budget or this consumption at a new price can be consumed anywhere on this budget line. Okay, so any consumption on this part at this new price takes us to this point, and we are indifferent. So the utility is quasi-concave, different alternatives. And the budget line is giving us convex, such that we can afford both of them. If that happens, then we can choose another combination, portion of this and portion of that, which gives us this point. So this budget line we've drawn here, suggesting that we are spending part of our wealth, we are spending part of our wealth on the first commodity, and we are spending the remaining on the second commodity. And that is the homogeneous rule. The percentage increase in price and the percentage increase in wealth, if they are the same, then the combinations bundle doesn't change. Again, if it happens that the initial bundle is affordable and it's convex, concave, then you can spend part of your wealth on either of them, and they should all be affordable. But with the Wallacean law, there has to be an exhaustion of your wealth. And that means that you can spend on both, and that gives you the new expenditure path, which could be seen at that point. So this is a very interesting thing, and I hope you would understand. If you have any other problem or you need further assistance, just link me up on the comment section, and I'm going to take it up from there. So coming to the close of this discussion, what we've said so far is that the consumer maximizes utility is subject to prices of goods and services, and his